Examples is all I have today. This is going to be notes. We're going to label it a section so you get some points for it. Yeah, God knows you like some easy points. Yeah.
Well, you gotta go to the Sioux, don't you? Yeah. Afraid of the Canadians, eh?
Yeah, dude. Did you know the Maltese riding moose up there?
Canadian Walmart.
So confusing. Yeah.
It wasn't the same.
Terribly confusing.
I've ever heard of anybody say they were afraid of Canadians.
Okay, think of it as a carnival game again. You've got a bag. You have 10 green spoons in it and 8 purple spoons, and the kid comes up and wants to play the game. They pick 2 spoons out. They win the game if the colors match. So you win if the colors match.
Sounds like a boring game.
Exciting game. Okay. I'm going to ask you, first probability questions I'm going to ask is, what's the probability that you win the game? So it's your job to convert this into a probability of what outcomes are you looking for.
Green.
Okay, so we want to convert this. This is where you have to come in. This is it. Now it's up to you. So you want to know what situations allow the kid to win. What has to happen? It's the probability of getting what? Green and green. Green and a green. Is that the only way they win?
No.
Or
they get purple and purple.
Or you can make that anything you want. What's the other way they win?
Purple.
Purple and purple. See where the words are so important here?
Yes.
Okay.
Doesn't sound like it's rigged.
No, not. Let's see what the list probability is. So, would a tree diagram help here? Probably, because I'm going to ask you like 3 more probability questions about this. So let's take the time to make the tree diagram. Start with the dot. Okay, the kid reaches in, draws out a spoon. What outcomes are we looking for? Green or purple? Green or purple? What's the probability that the first spoon out is green?
10 out of 18.
10 out of 18. Don't reduce. Or purple would be 8 out of 18. Okay, now they reach in and they grab their second spoon. Green or purple? Green or purple? Go ahead and fill in those 4 probabilities. I'll fill them in. We'll compare. See if you can do those 4 on your own without somebody telling you. Oops. Screwed up right off the bat.
I think I got it.
Okay, how did you do? Okay, see what I did right off the bat? Forgot to take 1 away. All right, now we're ready for this probability. So I'm looking for green and green. What does and tell you to do with your probabilities? Multiply. So you just follow the branches. All the thinking's been done over here. Or says put in the add. Purple and purple. And there's no overlap here, obviously. So there's nothing to subtract. But now it's just a calculator. Let's see what this probability is. This is a good game for a kid to play. 0.477, so about almost half the time.
This doesn't sound rigged enough for
Well, see, it's a little kid's game. You want them to win. A little less than half.
They don't want little kids.
Yes, they do.
Why do you think that'd be oval
Yeah, the
basketball?
carnies? The old.
So basketball.
True that. I thought James would be there, he said I was still like a half hour.
Let's say we're going to change the rules. This time you win. You win if they don't match. Is this a better game?
Got a 1/2.
Something minus the
You got 1/2? Are we disagreeing on the answer here?
Obviously.
Oh, let me see. I don't have the answer written down.
I got one. Just keep it how it is.
Okay. So, switch this into what situations are we looking to have happen?
Shouldn't it just be the opposite?
Green, purple, purple, green.
Green and purple, or purple and green. What's your educated guess here?
5 or 0.53.
You think it's the rest of this?
Yeah.
Let's see if it is. Green and purple plus, is it the other two? There are only 4 outcomes. Is it the other 2 branches? It should be then. So purple would be 8 and then 10. Yeah, there was only 4 outcomes. We had 2 of them up here, and now we've got the other 2. So yes, it should be the 0.533. We'll see if Noah gets that, see if he made a typo last time. Either Noah or Tony did. Because it should come out 0.533.
What do you know?
What'd you get, Noah?
5228.
522.
0.533.
No, let me try. Let me try.
Oh,
Oh, I gotta try.
no, it's didn't.
Only take a second.
Well, how did you round the 0.477?
Yeah, I rounded it up 1. Well,
The rounding just switched it around.
3 places.
I got 0.522.
Your mom made me buy her a dumb.
So does that mean it's 4/7?
It might be. I'm gonna look right now.
Are you dumb?
I can't get her to do that.
Oh my god, do you have no willpower?
Have you met her, Carol?
Nope. Why is it not
All
No, it governs her life.
Because it's rounded, it won't add up correctly. I don't know.
477?
Between her oldest child and that, she choose that code.
Oh, we're just not subtracting right.
What are you
No, I
wearing on
added
your-
up.
We are right.
I added the results of both and they came out right.
What is on your
Shoot.
shirt? It's like a
Mic,
tax
mic.
shield?
It's a microphone.
Like,
There's no microphone when you see one?
Why are you wearing that?
Because somebody's not here today.
Okay.
Cindy.
All right.
Yeah.
Yeah.
I've never noticed it before. What was it?
It was correct. 522.
She's not wearing it.
Let's
I thought
see.
you had like a heart monitor thing on it.
No. Number 2.
Do you want me to text Colin?
Today.
A sum of 6 or a sum of 7. So the 2 numbers added together have to give you 6, or the 2 numbers added together have to give you 7.
You have to know all the options.
So, you gotta kind of list them out. Which situations add up to 6?
You should give them the table.
1, 5, 2, 4, and 3, 3. Gotta get off the 5 over there. Anything else?
I know what I need, but I just.
Did you do 4/2?
Yes. Remember the branches all the way down? Remember? 5, 1. So what is the probability of rolling a 6? Do you remember how many outcomes there were for rolling 2 dice? Do you remember that tree? 36. So it's 6 out of 36. Or, oh, 1, 2, 3, oh, it's 5. Sorry, 5. My bad. I can't count. Then what adds up to 7 on the pairs?
1 and 6.
1 and 6.
6 and 1.
oh, you're going 6 and 1. So let's go with the 2. 2 and 5. 5 and 2. 3 and 4. 4 and 3. So there would be 6 this time. And when we're adding, we should always train our brain. Is there any overlap here? Are there any pairs that add up to 6 and 7 where they're the same here? No, these are mutually exclusive. But remember, when we're adding, we should train our brain to see if we need to subtract any overlap. So, 11 out of 36. So I was just reviewing that there's 36 outcomes. If you need to look back at that tree, you can. Okay, our last one. Old game show, Monty Hall game show.
Oh, the Monty Hall paradox, where you give your 3 doors and you open one, yeah.
I've never heard that.
Have you watched the movie 21?
No.
You've never watched it?
No.
Oh, it's so good.
I've never even heard of it.
Oh.
Right, that's the guy with the cards, yeah.
That's where he counts the cards. They go to Vegas,
Yes.
and they win all that money.
I think I need to see it.
Okay.
What about Ocean's 11?
Now,
like that
hold
one.
on, guys,
The
listen.
Ocean's movie is good.
If you watch this movie again, the very first day, the professor's in front of the class, and he asks them this probability question about, oh, I haven't asked it yet, but he asked the class to see who truly understands the probability. He was looking for the kids that have the right brain to get on his team. But this was the situation that he presented to the class to see who was a viable candidate to be able to count cards. So, the way the game show worked, you had 3 doors. We'll call them door A, B, and C. Okay. Behind one of the doors was a pig. Behind the other 2 doors were prizes, good prizes. Okay, and what you did was you picked a door, and he knew where the prize was, where the pig was at, where the prize was at. He would, let's see. No, there's 2 pigs and 1 prize. Sorry, 2 pigs and 1 prize. So you pick a door. He opens up, so he knows he knows where the pigs are at. He'll show you. Maybe this one has the pig. Then he asks you, do you want to keep your door? Do you want to switch to this one? Okay.
What happens if the one you picked is the first one you open up with the pig?
It's up to you. I mean, you get to, what should you do in this situation? Should you keep your door or should you switch your door? Or doesn't it matter because it's 50-50? That's the situation. Is there an advantage to switching or keeping, or is it the same regardless? That was the question he posed to the class.
The odds have gotten better for you.
Okay? So we're going to look at the whole situation. Should you keep the door or should you switch the door? So, here's the way we're going to look at it.
Switch.
It is not, well, choice.
Why do you have to change your answer?
The Monty Hall paradox.
You don't have to. It's your option. Do you want to stay with the door you picked or do you want to switch to the door you haven't seen? Does it matter? Then the person had to explain their answer. There is a correct choice here.
Switch.
So, it's stay
Your new odds would be better, but this is
and switch. All right. Let's just say, say what the prize was a car. Let's just pretend the car is under here. But you didn't know that. Let's say you picked door A to start with. So this is your door. Monty Hall knows the pig is behind door B, so he shows you door B. Now he asks you, do you want to keep your door A or switch to door C? If I stay with my choice, am I a winner or a loser? I'm a loser. If I switch,
winner.
I'm a winner because I switched over here to the car. Okay, so in that situation, switching was better. Let's say door B. He would open door A, show me the pig. Now he asked me, do you want to keep door B or switch to door C. If I keep door B, I am a loser. So if I stay, I lose the game. If I switch, I win the game.
Better to switch.
Now if I had picked door C, he'll open up one of these. It doesn't matter because he knows they're both pigs. So he'll show me B is the pig. Do you want to keep your door or switch to A? If I stay,
You win.
I win.
He has nobody.
If I switch,
Move it on.
I'm a loser. So, tell me, based on this, what's the probability I win given that I stay with my original door?
0.3333.
Where's that coming from?
1/3.
1/3.
I win once out of the 3 options if I stay. What's the probability I win if I switch?
There's
2/3.
2/3. So is it better to stay or switch?
Switch.
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 How does that work?
Okay, I'm going to go, if we go with more, now go back to the game show, the guy with the cases of money,
Deal or no deal?
deal or no deal. How many cases were there?
It's like 340.
25 cases? Let's just say 25 cases.
Yeah, it's
Okay.
25.
25. Okay, you pick one case. What's the probability that that case has the money? 1 out of 24. What's the probability that the money is out here somewhere else?
Wait, there's money in ours.
23
Well,
out
the
of
big money.
24. 23 out of 24.
23 out of 24.
Bill.
The case that there's what?
Oh, the million in it. Where's the $1 million case at? Sorry, the big one. We're looking for the $1 million case.
You initially pick one, and then you have to.
And then they keep eliminating cases, right? You keep picking,
And
and
then at the end, if you make it to the end,
you can either
choose
keep
to
your case
switch.
or switch, right? Remember at the end that keep it or switch
sell
it?
or you.
Yeah, there was all kinds, but let's just say we're looking for the $1 million case. So back to this. What's the probability that the $1 million is in the case that I picked? 1 out of 24. What's the probability that the $1 million is out here somewhere?
No, 20.
Oh, 1 out of 25 if there are 25 cases.
I was confused.
24 out of 25 chances that it was somewhere else to start with. Right?
Right.
That's pretty big. That's almost a guarantee that that $1 million case is somewhere else. So if you were lucky enough to eliminate all of these other ones, okay, they're all gone. You're down to 2 cases. The one you originally picked, or the one that was out in the mass, but you were able to eliminate all the bad ones. Where is it more likely to be at?
You take the deal.
Switch.
You take the deal.
Switch.
Well, you don't switch. You take the deal.
Switch.
See, we get it.
Yeah.
Take the deal.
Okay? So chances are, now go back to the 3 doors. When you picked your door, what's the probability that the car was behind the door you picked? 1/3. What's the probability that it was behind one of the other 2 doors? 2/3 chance it was over there. So there's a better chance of the door that you did not pick has it. And for him to eliminate one of the bad ones, he just doubled your odds that you're going to get it when you pick the other one. So it's a switch every time. If you could follow that.
It's a new car.
Thank you. Okay, that's all I have for you. You're not going to have one this challenging, but I thought it was kind of interesting
That was a cool.
situation.
That was.
It's
That was cool.
because really most people will say, oh, it's a 50-50 shot. I either got it or it's over 50-50. Well, not really, because it was 2/3 chance it was one of the other 2 doors to start with. They just increase your odds by eliminating one of those 2/3. So,
Trying to trick you.
yes, again. So I have a worksheet for you today.